Well, let's do all that again. I'm going to number my equations 1, 2, and 3. We have a 1, a -5, and a 13. -3, a 2, and a -13. A 1, a -1, and a 5. Again, it looks like x's may be the easiest to eliminate. So let's do that. I'm going to choose equations 1 and 2. If I add them together, x's already eliminate, so I can just leave them like they are. This is 0. This gives us -1y minus 4z equals 7. So this is equation number 4. Now I can choose equation 3, 2. So this needs to be a -5 if I want the x's to eliminate. So equation 3 gets to stay the same. What I'm going to do is multiply equation 2 by a +5. So everything in equation 2 gets multiplied by 5. So we have -5x plus 10y minus 25z equals 15. Now I can add these together. This gives me a -3y. -25 plus 13 is a -12z equals 15 plus 8 is going to give me a 23. And this is going to be equation number 5. Now I need to put together the two equations I just created because they both have a y and a z. So we have equation 4 and equation 5. And it doesn't really matter which equation you choose because it looks like something crazy is going to happen. Let's multiply the top one by a -3. If I multiply by a -3, that becomes a +12, which makes the z's cancel. So let's do that and see what happens. That'll give me a +3y, +12z, and a -21. If I multiply 3 times everything, I get this. Okay, the second equation, or equation 5, this is 0, and this is 0. We have 0 equals 2. That is not a true statement. If that's not a true statement that one or more of these planes are parallel, that means this particular system has no solution.